All right. Hello, welcome back to lesson 3 of this Intro to Processing course. Today we're going to be talking about variables and data types, so let's go ahead and get started. And so in this lecture, we're going to cover variables, different data types in processing and in programming, and also how to do some mathematical operations in processing. But you may be wondering, what is all this stuff and why is this useful to me? Well, if we look at what we've done so far what have we done? Well, we've learned how to draw things and add some color to things in processing. And so more specifically, we've looked at some concepts like how do we position different shapes and lines and things like that? How do we understand length and width within the coordinate system of processing? We also talked about how to add color using the RGB color system. However, everything that you've drawn so far, it's been very, very manual right so far. And what I mean by that is that if you want to draw a circle at this position, you had to figure out exactly where, to put that circle and exactly how big to put it. If it didn't look right, you just had to play with the numbers until, it looked right. And so, maybe you did something like you drew maybe a Christmas tree where they're like triangles stacked on top of each other, where you knew you wanted the bottom triangle to be maybe 2 times wider than the one on top of it. Well, you had to kind of do all that math yourself, right? You had to figure out, well, if the width is this, and you divide by 2. You had to do all this figuring in your head probably to make that work. And so, which is fine, nothing against math here. But today we're going to talk about how to make that a little bit easier on you using programming and some programming techniques, specifically using variables. And so an example, what do I mean here? Well, let's say I gave you a challenge of, draw me a house, something like this. And let's say, you figured up all the dimensions of the rectangle and the triangle and then the rectangle for the door and everything. And you're like, okay, here's my house, Chris. I feel pretty good about it. What do you think about it? And then I said, oh, I like that, but I kind of wish it was a little bit wider. Could you just make that rectangle wider for me? Well, if you did that, what would happen is it would make the rectangle wider, but it would mess up everything else. The triangle wouldn't scale with it because everything you've done, remember, you just hard-coded in the position and the length and width of everything. So if you change the width of the rectangle, that doesn't change anything about that triangle command, right? And so then, if I had told you just to change that one thing, change just the width of that rectangle, it breaks everything and messes everything up in your drawing. And as far as I'm concerned, that's pretty lame. We don't want that. And throughout this course, we'll kind of go over techniques. We'll introduce a new concept or something, but then we'll talk about how we can make things much easier on you using more complicated programming techniques. And so we're going to take our first step in that direction today using variables. And we're going to talk about how if you use variables and you just change the width of this, if you define things correctly, it actually will scale the whole house at the same time. And in fact, I'm going to show you kind of what I mean by this. First, I'm going to show you maybe what the program looks like in terms of drawing the house without variables. And so this type of stuff should look very familiar to you. And so what have I done in this? Well, first I set the size of my window to be that size. I then set the background to be a certain color. It's that should be make background kind of a black gray. And then I just, I set the color of my rectangle. Then I drew my rectangle, just told it the position, told it the width and height. Same thing, my roof. I made the fill of the roof, drew the triangle for the roof, door, fill, rectangle for the door. If I click play here, you'll see, here's my house. That looks pretty neat. It's that same picture that I showed you before. But just to show you what I mean, if I want to make it wider now, well, I know that this is the x position, y position width of my rectangle. So let's say I make it wider. Let's say I make it 400. If I click play now, you'll see I made this wider, of course, which is nice. It's what I wanted. But the triangle did not know that it should scale with that. And the door did not know it should recenter itself. And that kind of makes sense, right? Because if I look at this triangle command, well, it's just controlled by these numbers, and these numbers have not changed. So the position and width of the triangle have not changed either. Same thing with the door. These are just numbers, right? I didn't tell it to, even though I changed the width of the rectangle, this did not know it should change with it. So that can be a problem, right? But using variables, and I won't show you too much of the code here, but here, I have some variables here, and we'll talk about what this means here in a second. But you see, if I press play here, I have my house. I also added a doorknob for fun, right? But if I just change one thing, like the width, and change the house width to 400, click play, you see the whole thing's wider, but the roof went wider with it. The door is recentered. nothing broke. It still kind of maintained the integrity of my entire drawing, which is really, really cool and useful. I can mess with any of these. I can say, make my house height, let's make it taller, right? And then press play, you see now it's taller. In fact, it's so tall that it passes my window. But, it's very, very easy now for me to just play with some of these numbers. I have a nice fat door here. It's a nice wide door, so it's really easy now for me to change things and doesn't break things. And so I'm going to talk about with you today how you can make this work for you in anything that you want to do using something called variables. And so to continue on, if only there's a tool that would help us do this, and there is. It's called variables, and we're going to go over that today. And so, what are variables, right? And so, well, variables, that's something that has a value that can vary or change. And so you might have heard this term lots of times in a math class or something, maybe in algebra or even calculus or something like that, right? Where you have like, oh, here's a variable, right? A lot of times you would say X is a variable or Y is a variable or something like that. But all that means for it to be a variable, all that means is that it can have many different values, right? It's the opposite of a constant. If I said this is a constant, and it's like 5 is a constant, well, 5 is always 5. It never changes. It's always 5, right? It's a constant. But a variable can have different values at different points in time. And so, if you're in math class, right, you can say, well, let X be 2. So right now X is 2, but you could make X equal to 7 or 1.68 or 1,500,000, right? It could have many different values. So that's why it's called a variable. There's many possible values it could have. Same thing. You might have seen like an equation in math class that's like y equals 2x plus 1 or something like that, right? But we know that since X could be many possible values, X could be 1, X could be 2, X could be 1,000,000. Y could also have many different values, right? Because if X is 1, that'd be, let's see, 2 plus 1 is 3, so Y would be 3. If X is 2, then this would be, 4 plus 1 is 5. Y would be 5, right? So Y here would also be a variable because it could have many possible values, right? And so this is very similar to what a variable is in programming, but it is a little bit different. There's some very important differences. Mainly in math class, a variable is always like a number, right? It's always, an integer, or maybe it can have a decimal or something like that, right? But for programming, variables are a little bit different. They still vary. They can have many possible values, right? And they can change over time, but it can have many different types. And we're going to review these a lot throughout the semester, but I want to kind of introduce to you this concept right now about how there's many different types of variables in programming. And so one type is like an int or integer. This is just a number without a decimal, right? So if I have a variable that's equal to 2 or equal to 78 or equal to 5,000,000 or 9,000 or whatever, that would be an integer or a variable of type integer, right? A lot of times that's shortened for as int in programming, but that's one type of variable. So a number that does not have a decimal. And so if we have one type that's a number that's not a decimal, you can imagine there's also a type that is a number, but it has a decimal. And that's called a float. It's a floating point value. It's a float. And so that's just a number with a decimal. So a float type variable could be equal to something like 1.6, 0.5, 800.66541, whatever. If it has a decimal, that variable would be of type float. Now, this doesn't seem too strange or weird probably to you because it's very similar to what you've done in a math class, right? Where, it's equal to a number, maybe it changes over time or whatever. We just have discriminated between, if it does have a decimal or not. However, in programming, you can even go beyond just numbers with your variables. You could have a variable of type string. A string is just a sequence of characters. So it could be something like, hello, everyone, like this word, this sentence, this brief sentence, hello, everyone. A variable can have that value. So a variable could be equal to that sentence. It could also be equal to, like my name. It could be, I got a variable called name or something that's equal to Chris. Or I could have a variable that's equal to the sentence, my favorite food is chicken fajitas, or whatever, right? You can have a variable that's actually equal to a sequence of characters, a string of characters, if you will. It can be equal to one character. It can be equal to the letter A or whatever, right? And so that will end up being very useful for us later on. Not so much today, but you can have variables be equal to words and sentences and things like that, and we call that thing a string. You can also have a variable in processing be equal to a color. And so we've used color already in this course where we had, the fill of shapes, and you could change the stroke color of shapes and lines and the background color, right? Well, you can actually make that be stored as a variable, which could be useful because let's say you want to change the color of something over time. Well, you can make that equal to a variable, so it could vary over time, and then you could have that color change in some cool, fun way. And so, an example could be you would write it like color 255, 0, 0. From what you've learned, what color would this be? Well, this would be red, right? Because this first value, if we were thinking about RGB, well, the first one's R, which is red. 255 is the max value. G is a 0, so no green. B is 0, so no blue. So this would be a red color. And then you could have that change over time in some cool, fun ways. Now, there's also a variable type called Boolean. And this is probably a bit weird, something you haven't heard before, most likely. A Boolean is just something that can be either true or it can be false. So it's still a variable in the sense that its value can change over time, but only has two possible values, either true or false. This will end up being very, very, very useful for us later in the future. We won't talk about it too much today in detail, but I want you to be aware that there is this thing called a Boolean that can have a value of true, it can have a value of false, and it can change between those two things given different conditions in our program. And there's more besides this, but this is kind of I feel like the core data types or variable types that you'll see in programming and processing. And so I just want to kind of introduce to you this concept right now. And so that being said, let's continue on. There's a few different, whenever we talk about variables in programming, it has a few different attributes, right? Namely, it has three things we need to talk about. One is the type, what type of variable it is. This is what we've already talked about. Is it an int? Is it a float? Is it a string? Blah, blah, blah. We need to talk about the type. Another thing that's important to talk about with a variable is the name. So what is this name of the variable? Now, in math class, the name would be something like X or Y. If I say X equals 5 in my algebra class, the name of that thing is just X, right? We just call it X. What's kind of cool in programming is that for your variables, it doesn't have to be a letter name. You can name it anything you want. So you can name it something like, you can name have a variable named Bob, or you can have a variable named, Foxtrot Alpha, or a variable named X, even if you want to just kind of stick to the basics. You can name it whatever you want. You can name it Chris's most fantastic, beautiful variable. Who cares? You can name it anything that you want to, which is really kind of cool and really kind of fun, right? But it also turns out is very, very useful because as we write our programs, we have all these variables and things kind of written out that's really cool and helpful to us. But if we come back to a program that we written like a month ago or something, it can sometimes be hard to figure out what's going on, right? But if you have variables that have kind of intuitive names, so the name kind of matches what it does in the program, it can make it really easy to read your code and understand what's going on. And so an example, what I like to do is, I gave you that house example here, a few slides ago where it has a width and a height and all this good stuff. It can be really useful if you name your variables something related to what it does. So if you have a variable that controls how long this house is, I would call that variable something like house length. So the name of that variable is house length. Instead of being called something like X or Y, it's called house length. That's going to be the name of the variable. Let's say I drew a robot, right? And I have the color of that robot stored as a variable. I would name that variable robot color. So then, when I read this and try to write code with that, the name kind of makes sense because it's directly describes what it does, right? But let's say I want to have a variable equal to like a sentence. It's a string. It's equal to a sentence, let's say. And let's say it's going to print out a message to me whenever I press a button or something like that, right? I would maybe call that variable something like message. So I would call it message because, what type of thing is it? Well, it's like a message, right? So I would give it a name that kind of matches what it does. And so that's something to keep in mind. It's really, really useful. And so just while we're here, I have these three examples here, house, length, robot, color, and message. What types of things do you think this would be? What type of variable do you think each thing would be, just given the name, right? And by type, I mean these types. It'd be int, float, string, color, or Boolean. And so house length, robot color, message. Take a second just to think about what each of these would be, what type. I'll give you a second. And so what it would be, just based on the name, now I can just tell you, house length, well, that's like a length. It's probably going to be some type of number, so it's probably going to be either an int or a float. Since length is usually like length in pixels, you can't have like half a pixel or anything. So that's probably going to be like an int. So the type of this variable would most likely be an int. The type of this one, robot color, well, I think that's pretty straightforward. It'd be type color, right? Why would it be called a robot color if it wasn't a color? And then the message, well, I think a string most likely, because a message is probably going to be equal to like a sentence or something like that, and that would be stored as a string. And so you can see that by being aware of what conscious of what you name these variables, they can even give you a hint to even the type of thing that they are. So if you're really conscious about what you name them, they can be helpful to you later on. And just remembering what type of thing it is and what it does. So that's really, really useful. And I'll give you some more concrete examples about how we write this in code here in a second. But while we're on the topic of naming variables, I want to talk to you about some naming rules and conventions about naming things. And so in kind of Java-based languages, including processing, what we tend to do when we name a variable is we use what's called camel case convention. And so camel case, all that means is, let's say, here's our variables, is that what you usually do is, first off, there's no spaces in the name, and that is required. You cannot have spaces in the name. So even if I go back to this one, you see house length, robot color, and message. There's more than one word here, but there's no spaces. And so you have to have it that way. I can't have house space length, because if you do, the language thinks those are two different words and two different things, so it gets all confused. So if you want that to be a variable name like house length, there cannot be any spaces between those words. But what you should also notice is that usually, and this is, I would recommend following this convention, is the first letter in the name of the variable should always be lowercase. And then you should not have any capitalized letters unless you get to a new word in that variable name. And then that letter would be capitalized. So you can see house length, that's two words there. The first, house and length. The first word is lowercase all the way through. It's lower case, even the beginning letter. But for any word after that, I have a capital letter for the first letter of that word. And so an example, in fact, I'm going to even get out of this. And, let's say I had some really long variable name like house length. Or here, let's do something like this. Let's say I had, Chris's best amazing variable name, right? Let's say this was my variable name. If you want to make this follow camel case, what you need to do, there's several words here, Chris, best amazing variable name. Well, to follow camel case, this first one should all be lowercase, but then for every word afterwards, it's all lowercase except for the first letter. And so this part is not required if you don't want to use this camel case. You don't have to, but I highly, highly recommend it. It makes things easier to read. If you look at code online, it usually follows this standard. And so, I highly, highly encourage you to kind of follow that as you write code in Java or processing or a similar language. And so the reason it's called camel case as well is that if we think about a camel, it has a hump, right? And so, how does a word written in camel case looks like? Well, if we imagine that a capital letter is a hump, since everything starts off as lowercase and then kind of in the middle of the variable name, there's a hump. That's why it's called camel case, because it kind of goes lowercase, lowercase, uppercase, and then it goes back to lowercase. So there's this little hump in the middle of the word. So that's why it's called camel case. Kind of like, it has a hump here. So we kind of level it out, go up some, and then level back down. And so there is another variation of camel case, which is fairly common. I see people use this, and that is instead of having it be no space and you have the next letter of the next word be capitalized, instead you just put like an underscore. That's technically not camel case, but it's also a fairly common standard. You don't see it quite as much, and I don't like it as well. But if you really like that, that is a convention. As long as you're consistent with your variable names, you can do it like that. And so hopefully that makes sense. I'm going to move on from here. And so now let's talk about how we actually use variables in processing. Well, first we need to make our variable, right? We need to declare it. It's called declaring whenever you make a new variable in processing. And so to declare your variable, you need to do this right here. And I'll show you what this actually looks like in code in a second. But you need to say what the type is, then you have a space, and then you have the name, and then of course a semicolon, because you always need a semicolon. So an example, if you want to make a variable called house length, well, what type of thing would that be? Well, it's going to be an int, an integer. So you need to actually type out int, and then you need to type out the name. In fact, right here, I have forgotten my semicolon. So let me go back here. Semicolon, semicolon. See, even in my slides, I forget semicolons sometimes. So it's going to happen to you all the time. But what you need is you need to put the type, the name, and then a semicolon. If you do not put the type, it will not work. And so let's step away from the slides for a second, and let's go to an actual example. And so here, I went ahead, I have, you see I put some comments here just to help organize my code. You can do this as well. The other day, we talked about using the double slashes. Whoops. Let me undo. I did something wrong there. Go to here. You know, we talked about using double slashes, and I can leave a comment like this is a comment, right? So this, which is nice, and so I can leave myself notes. But what I've also done is you can, if you want to, if you have a comment that's going to stretch multiple lines and you don't want to have a double slash on every line, because that's annoying, what you can do is do slash asterisk, and then go down some, and then say asterisk slash, and then anything in between this will automatically be made a comment. And so that's just a kind of a helpful way of having, you know, many lines of comments without having to do so many slashes. But anyways, I just made a comment here, say variables, because I'm going to make some variables here. And so let's say I want to make a variable called, you know, circle diameter, right? The diameter of a circle. Well, what type of thing would that be? Because remember, to make this variable, I need to have the type and I need to have the name. So what type of thing would the circle diameter be? Well, that type of thing would probably be an int, right? Because it's going to be measured in pixels. And so that's going to be an int. And you see when I type int, it actually changed color to orange. This is processing's way of telling me, hey, I recognize what that thing is. I know what an int is. So, you know, it's telling me that it knows what that is. Now note, I did not put integer, because put integer does not know what that is. It just shortens it to int. And so make sure to have int. And then if I want a variable to, you know, represent the diameter of a circle that I'm going to draw or something, you know, what would that be? Well, I'm going to say, you know, what's a reasonable name for that? Well, we could just call it something like circle diameter. And then, you know, just give me a red line. Why is that? Well, I need my semicolon. And so now I have a variable. I've actually made a variable here. Now you see it's giving me this yellow line here, and it gives me this error. Yellow lines mean it's not like an error. It won't break anything, but it's usually like there's something kind of funny going on. And so if I read this error, it says, hey, you made a variable, but it's never used. And so that's fine because I haven't used it to actually draw my circle yet. We'll do that here in a bit. But yeah, so this is how you would make a variable. And so let's do the whole shebang, right? Let's because what do you need to do to make a circle? Well, you need the x position, the y position, and then the diameter. We already have the diameter. Let's go ahead and make the x and y as well. And so what type of thing would be the x position of the circle? Well, I think that's also going to be an int. And then what do we want to call this variable? Well, we can call it something like circle x. Something like that. And if you want, you know, I call it circle x. You can shorten this, right? You can call it cx or something. And you can call circle diameter something like c diameter if you want to. You know, it's up to you. I tend to err on the side of being a bit more wordy, as long as that wordiness helps me understand what the variable represents. And so if I read circle x, it's pretty obvious to me that this is the x position of a circle, right? But if I read cx somewhere, you know, I'm like, well, what is c? You know, maybe it's a circle. Maybe that makes sense in the context. But, you know, there could be something like, you know, what if it stands for corner or container, or, you know, something else that's going on in your program? I don't know. You know, you never really know. But if you want to go that route, you can. There's nothing wrong with shortening your variable names, as long as they make sense to you. And so we have the x position, we have the diameter. Let's go ahead and make the y value. So how do we do this? Well, we need to have the type and the name. So what type of thing would the y value of the circle be? I think int as well. And the name, I'm going to just call mine circle y semicolon. And so you see, now I have these three variables. They're made. Now, right now, they're actually not equal to any values. We're going to talk about that here next. But this is how you would make these variables. So hopefully that makes sense. I'm going to go back down to my slides. So remember, you need a type and you need a name for your variable. Now, we need to now talk about how do we actually give these variables a value, right? And so, because if we think back to our math example, right, something like here, like in math, we have a variable called x, but it has a value, right? Like this x is equal to 2, or this y is equal to the value 2x plus 1, right? So, variables are not useful to us unless we actually give it a value to hold, right? And so, how do we give something a value? Well, first off, it's very, very easy. But this is called initializing it. When you first give the variable a value, it's called initializing that variable. So when you just make it, when you do something like this, where you just give it the type and name, when you just make it but do not give it a value, that's called declaring the variable. So we declare it, we've made it, but it does not have a value yet. Once we're ready to actually give it its first value, that is called initializing. So declare and initialize. And the way you initialize a variable is very easy. You just say the name, and then you say equals whatever it is you want it to be equal to. And so if you want your house length variable to be equal to 100, you just say house length equals 100. And then, of course, you need your semicolon. If you want your variable to be equal to your string, you just say message is equal to whatever your string is. A string has these double quotes around it. That's what makes it a string, so that's why these have double quotes. And so let's go ahead and jump into this example, right? Let's say, I have these variables, they're declared. So I'll even make a comment here, declaring my variables, right? Now I can come down here and I'm going to initialize my variables, meaning let's give them a value. And so let's give circle x a value. How do we do this? Well, if we just say circle x, that's the name of the variable. If I say equals, and then I can just give it whatever value you want. So I'm going to say like, what's my size here? I forget. 600 by 400. I'm going to say, let's put it towards the middle, 300. Boop. Semicolon, of course. I can then say circle y equals whatever value I want. I'm going to say, 200. And then circle diameter, I'm going to set it equal to 50. Something like that. And so now these variables all have different values associated with them. And so just to show you that this is working, below this, I'm going to say print line. In fact, I'm going to check. I'm going to make sure I don't have other stuff. Yeah, okay. I'm going to say print line, parentheses, and then I'm going to print out circle x. Now, if you remember print line, it's going to print something out in the console, which is this black area right here. What do you think is going to happen if I print out circle x? Well, if we just click play and try it, you see what we see. There's nothing in my window because I didn't tell it to draw anything yet, but it prints out the value 300. So it prints out the value of circle x, which is 300. Now, what if I change circle x to be 200 and press play? It then prints out 200. Hey, there we go. And so, if I made like a different variable here, let's call this like string test variable. And then I say down here, test variable is equal to, this is a test. Hello, whatever, smiley face, whatever. Since this is a string, I did put this in double quotes. If you want it to be a string, it has to be in double quotes. But now if I say print line test variable, click play, it will print out my wonderful message. It says, this is a test, hello, with the happy face. And if I change it and I say, if I just say test hello, click play again, you see it prints something else differently down here as well. So whenever I change the value of my variable, and then whenever I try to access that variable by printing it or doing something with it, it will have that value that it was last assigned. So hopefully that makes sense to you. And so, okay, so let's go on and go from there. I do want to say you can declare and initialize a variable at the same time. There are different times when it's useful to do it in different spots, but we'll go over that throughout the course. But I do just want to show you how that works. And so you can see here, what have I done? Like in these examples. Well, first I said the type and then the name. So that looks like I'm declaring something. But then I also said equals a value. That looks like initializing something, right? So like this bit looks like it's declaring. So declaring. But this bit looks like I'm initializing, right? So there's kind of some overlap there. But it turns out if you write this whole thing like this, it works just fine. And so I can give you just a very quick example of that. And so let's say for my test variable, let's say, let me erase my whiteboarding right here. Okay. If I just come here and say, here I declared it. Let's say I want to declare it and give it a value all at the same time. I'm just going to delete this right here. Oops. If I go here, if I want to declare and initialize at the same time, I can just say string test variable. That's the declare bit. And then to initialize, I can just say equals. Here, you are awesome. Do whatever I want. Woot woot. And you can see it's good to go. It's just fine with that, right? And then I'm still printing out my test variable. So if I make that a little bit bigger for you. So this declared it. I set it equal to this value all in one line. And then I'm going to print it out. If I press play, you see it prints out, you are awesome. So it does that for you. So we'll talk about why that's useful and why that should not be used at different times. But that's for the future. We're not too worried about that right now. But I just want you to be aware that that is something you can do. And so one last thing I want to talk about is one way you can think about variables is a bucket analogy. This is a fairly common way of thinking about variables. But you can think of a variable as a bucket, right? So you have a bucket, right? And you can imagine that you can have different buckets that hold different things. So like if you're like working outside or a farm or something, right? You'd have, well, this bucket holds water. This type of bucket holds only feed. It's not allowed to have water or anything of different types. This bucket's supposed to have, tools or whatever, right? You can have buckets that hold different types of things, just like variables can have different types as well. You can also label buckets, right? So if I have a bucket, I can say, okay, I'm going to call this bucket X, or I'm going to call this bucket bucket 1, or I'm going to call this bucket, house length, maybe if you're thinking about previous examples. And so by having, thinking of buckets thinking of buckets in this way, they kind of relate to variables because you can have a bucket that has a name and can only hold a certain type, and the type or the thing that you put inside the bucket, that's going to be the value of that bucket. And so, for example, let's say I have a bucket here, and the name of this bucket, the label that I gave it, is X. And then if I look inside that bucket and look inside of it, and I see, I'll see the number 5. That's the same thing as saying I have a variable X is equal to 5. It's the same thing. So this bucket's like a variable that can hold different things. And just like variables, remember what makes a variable a variable? Well, it can change what it has over time because, maybe I want to later on change X to be equal to 10, right? Well, same thing with a bucket. If you have a bucket that's holding something, you can always dump it out and put something else in its place. So then if I say, if I then later said X equals 10, that's just like me taking my bucket, removing the 5, and then putting in 10. So then later on, if I look inside bucket X, I'm going to see the value 10. And so, this can be helpful for people. If you like thinking of variables in this way, this is a very good analogy for doing so. So hopefully that makes sense to you. That being said, I do want to say there are some built-in variables in processing. So far today, we've talked about making variables, ourselves. We can name them whatever we want. We get all this freedom, right? But there are actually some built-in variables in processing as well, and they have certain values. For example, there's a variable called height, and so it's like if you type in the word height in processing, it's already a variable. It has a value that processing has given it. This represents the height of the window. And very similar, there's a variable called width. That's going to be the width of the window. And so what does this kind of mean? What value would width and height have? Well, if I pull up my processing sketch again, you remember how I have the size function here? I set the size of my window. Well, actually, you know what? Here, I'm going to delete this line here. I'm just going to do print line, just right here. It doesn't matter where. I'm going to print line width. See, when I type in width, I have not defined width anywhere in my program. I have not defined it. It's not a variable I've made, but it's something that's built into processing. And if I tell processing to print this value and click play, you'll see it prints 600. Well, if I look at my size, what did I tell it the width to be? 600. So if I change 600 to be 800 and then click play, you see now it prints 800. So it prints the width. Same thing if I print height. I never defined it. It's just built into processing. But it's going to be equal to whatever this is. If I click play, you can see that, boom, it prints 400. So we're good to go. So I just want to make you aware that width and height do exist, and they're built-in variables that we do not have to define. So that's kind of useful. And we'll actually go over a lot of examples in the future about how this can be useful for you in terms of drawing and do different cool things. But okay, now let's go back to our example here. I'm going to get rid of this. I've made some variables, circle X, circle Y, and circle diameter. Let's actually use these to draw a circle, right? Like what use is this if I don't use this to actually draw my circle? And so they have values, 200, 250. In fact, I think I might want my X to be 300, let's say. And so I'm going to go down. You can put this wherever, but I just have some code here. I want to draw a circle, let's say, using these variables. How do I do this? Well, how do you draw a circle? Well, it's just the circle command, then parentheses, and then I'm going to put in some different values. What do you think I should put for the X? I could put 200, or I think I said 300, right? I could put that, because that's what circle X is equal to. However, that's just a number. That's just what we did the other day. That's no fun. That's no cool. We want to go ahead and use our variables. So instead of putting a number here, I'm going to put my variable circle X. So then for my Y value, what should I put? I'm going to put circle Y. And then finally for my diameter, what I'm going to put? I'm going to put circle diameter. Boop and boop. And so if I click play here, let's see what happens. It draws a little circle there. And I'm going to change my size back. I'm going to make it a little bit skinnier. There it is. Yeah. So I've drawn a circle using my variables. Now, okay, big whoop, how cool is that? Well, what's kind of neat, if I go back up to my variables and I change some values, let's say I change my diameter to be 100, and I click play, you'll see that changing this variable up here transitions down and changes what this circle command actually does, because now circle diameter is no longer equal to 50, it's equal to 100. So you can imagine I took the 50 out of the circle diameter bucket, and I put a value of 100 inside the circle diameter bucket, and then that changes how the circle is drawn. Same thing, I can change the X and Y value if I want it more to the right. I can say 400 here. Click play, it moves to the right. If I want it more down, do I need to increase Y or decrease Y to go down? Hopefully you remember I need to increase it. I need to make it bigger because it's kind of opposite what we're used to. So I can make this 300. Click play here. And there you go. And so you can see I can start manipulating things like that. It's pretty cool. So that's how you use variables. But I do want to go over one other little concept here. And we'll talk about how variables makes this really, really useful. And so that's going to be mathematical operations in processing. Because cool enough, you can do math in processing. You can add, you can subtract, you can multiply, divide. The way you do this is using the symbols that you may think. If you want to add two things, you would use the plus symbol. Makes sense. You want to subtract, you use the minus symbol, the little tiny dash. Makes sense as well. Multiplication, use the asterisk. That may be a bit new to you, but it'd be the asterisk symbol. That's how you multiply two things. Division is like the slash, or excuse me, slash for you. And then modulus is the percent. What all modulus is, and I don't think we'll go over this really too much in this course, but it's like division, but it just gives you the remainder. But you don't have to worry about that right now. But you can do some basic math things in processing. And so just to give you an example of that, let's say I'm going to do, right here, print line 5 plus 2. So I can add these two things. If I click that, it's going to print it down to the bottom. It prints out 7, which is correct. 5 plus 2 is 7. I do 5 minus 2, 3. It works. Cool. If I do 5 times 2, 10. Anyways, it's working. And then if I do 5 divided by 2, it does 2. And so we'll talk about why this happens later. But let's make this just something even right now. So 6 divided by 2 would be 3. So we'll talk about why 5 divided by 2, it told us 2, said 2.5. But that'll be for a future lesson. That has to do with data types and things like that. But we won't worry about that now. And so we can do some math. Okay, cool. Why am I bringing this up now when we're talking about variables? Well, it's because we can actually start making some mathematical relationships between different variables. So let's say I want to draw another circle here in my window, right? But I want this other circle to always be 2 times bigger than my first circle. How do we do that? Well, first, let's make some new variables here. Let's make some variables for our second circle. And so I'm actually going to change these variables. Instead of being circle x, I'm going to be calling it circle 1x. So it's the x value of the first circle. Circle 2, or circle 1y, excuse me, circle 1 diameter. Now, if I change it here, you see now this is mad. It's because I've changed the name of the variable. So let's go ahead and change these names to match it. And then I need to change these as well. Do-do, do-do, and do-do. Okay, cool. Now, the reason I'm changing these to circle 1 is because now I want to make some new variables for the second circle, which is also going to be the x, y, and the diameter. I'm going to call these circle 2x, semicolon, int circle 2y, semicolon, int circle 2 diameter, semicolon. And then I gave these some values. Right now, I'm just going to give, circle 1x a random value. 200, sure. Circle, 2x. Circle 2y, I'm going to call it, 100, I don't know. And then for now, I'm just going to give this a number. Circle 2 diameter, I'm going to say it's also equal to 100. Let's see. Then I'm going to go back down here. Circle 1, I'm going to draw my circle 2, using the circle command, of course, but using the circle 2 variables. Circle 2x, comma, circle 2y, comma, circle 2 diameter, semicolon. Let's go ahead and click play. Let's make sure it works. It does. There's my first circle done here. Here's my second one. But now I want to talk about what I really wanted to is how can we use math to help us do some cool, crazy things here, right? And so how can I make it where this second circle is always 2 times bigger than the first circle? Well, if we think about using math, I have the circle 2 diameter here, but that's the value. What do you think would happen if I said make it equal to 2 times circle 1 diameter? So I'm doing something kind of cool here, right? I'm using one variable to help me define another variable, right? In fact, you've probably seen this before. We've even shown an example of that today when we talked about some math examples. When we looked at this, y equals 2x plus 1. That's you defining y in terms of another variable. So you define one variable in terms of another variable. We're doing the same type of thing here in processing, where we have one variable being defined by another variable. But let's see what happens here. If I click play, you see, hey, look at that. I have this one has a certain diameter. This one turns out has 2 times that diameter. What's really cool about that is if I make this one, if I change the value of circle 1 diameter, let's say to 50, that change is actually going to transition down to also change the circle 2 diameter. So if I press play, you see this one got smaller, but this one is still 2 times the size of it. So that's pretty cool. If I made this, let's make this 200. Let's make it big. Let's see how big the circle 2 gets. Set of fun. Really big, pretty dang big. But you see, it kind of holds a relationship together between the diameters of these two things. That's pretty dang cool. And that's actually going to be the key to making sure that, like, let's say, go back to that house example I showed you. Here, before how we did things without variables, if you changed one number, all the others stayed constant, and so you would end up, with a jacked house like this. It wouldn't work right. But let's say you had a variable that was like house width or something, right? You could use that to do some math to make sure that the triangle of the roof always stayed with that house. And so that's pretty cool. And so the challenge here is I want to encourage you to draw a house. It should have, the main house, a roof, and a door. And for now, you can start off just by using numbers, do what you're comfortable with, get it to where it looks how you like it. And then after that, what you can do is start making some variables. Once you have some variables, you can start defining relationships between these different things. And then you should have it where at some point, if you have like a bunch of variables and you just change one of them, if I press play here, this is how it starts off. But then once I do something like change that to 400, it gets wider, but everything else also changes with it. So it's very, very cool and very useful. So that's my little challenge for you. If you're in my class, we will talk about this in person because it's a pretty actually hard challenge. It's definitely possible. You have all the tools to do it, but it can be a bit tricky. And so I know you can do it, though. And if you're in my class, of course, come talk to me. We will hash through this. And so thank you so much for your time, and I will see you next time.